Okay, so hey, thanks everyone for coming. Thanks for the organizers. So it's going to be a lightning talk. I'm not going to go deep into Orleans details. So anyone that's come looking for that probably going to be a bit disappointed. There is hours of content from Microsoft online where they deep dive into the internals. YouTube is really good. So if you get a taste of it today and you think it could be good for your project, I can point you in the direction of some good content. The other reason I won't go deep is because I'm not actually an active developer on the project. So I have been working alongside it for quite a long time and directing the team. So I have real world experience of a decent sized project. And particularly I wanted to dig into, is Orleans a good match to a DDD entity? So it was a bit of a journey of discovery going into the code and trying to work that out. There we go. So yeah, it's me. I've been doing this for a long time. Why I'm here at the DDD meetup is because I've seen a really strong correlation in the past of code that's written with DDD principles and the chance of success of that project. I'm measuring success by a simplified metric here of code that's in production for more than 5 years, delivering value to a customer. I'm currently working at Evergen, principal architect there. So you need a bit of an introduction into what Evergen is. They do distributed energy resource optimization and control. So that's things like residential and commercial batteries, hot water or controlled loads, electric vehicles. So you might hear these things referred to as virtual power plants. So we can optimize an individual site or control a fleet of them together. Dispatch. So I thought everyone might have a bit of an idea of Orleans, but some people haven't even heard of it. So for a start, it's from Microsoft. So it's built in .NET. It's a large framework, building distributed applications, concurrency, high throughput. It's built on the follows the reactive manifesto, like scalable, resilient, elastic, and message driven. And it uses the actor model. Yeah, it's a bit more background on it. It was very famous a long time ago with the launch of Halo. I think that was like the big fancy thing that they launched on, and it was very successful inside Microsoft. So then they open sourced it a few years later. It's still running lots of platforms inside Microsoft. I think another one was Skype, I think, and I don't know if that's still around. I think even the Microsoft Cloud, like the management of that is running on Orleans. So Xbox, yeah, yeah. So most of the examples you see online are all from Microsoft. So I think that's where I come in. This is a different business case that is using it in the real world. So we said Orleans is based on the actor model. So this is an idea that's been around for a really long time. Collection of independent entities, so that word's coming up already, called actors that communicate with each other by sending messages. So they have state, behavior, and a mailbox for receiving those messages. Interesting aside here is that Alan Kay said that like the actor model is kind of closer to what he originally intended OOP to be, but it went in a different direction along the line, especially the message passing. This is also from the original research paper. It's like the actor model is very powerful, but lots of the large-scale implementations, Akka and Erlang, were very difficult to use, like high barrier to entry. Especially Erlang was very inaccessible. So Microsoft launched Orleans to make that available to the general public, the average Joe engineer. Since that time, Elixir has come out, so I don't know if Elixir is a bit easier to manage than using Erlang itself, but I don't have any experience with Elixir, so I'll stick to Orleans for now. Yeah, so inside Orleans, we have things called grains, fundamental building blocks inside Orleans. And you can call it many things. An actor, Microsoft marketing like to call it the virtual actor model. They don't like to say it's just an actor. An OO type model that exists when required. That's part of the Orleans nicety, that it like hydrates the object when it needs to be, and then it can go to sleep and disappear when it doesn't need to be. Another marketing term is a cloud native object. Or the one that really resonates with me is identity plus behavior plus state. This is kind of explain to me what the actor model, like the value it brings. And this is where I get to, it feels a lot like what I think of a DDD entity to be. Yeah, but maybe the difference in Orleans is that it can keep that state in memory. That's the big optimization you'll get by using Orleans. So of course, what is an entity? Primarily identified by the ID, goes through a life cycle, has properties, has behavior. And this one I've just added at the end. I'd like to say they're the things that we've discussed with domain experts. So like, what are those things in your business? So then I went down the path of asking, like, is a grain an entity? So to answer that, I'll step back a bit more to what we do. So this is what Evergen does. And why do we need an actor model for distributed energy resource optimization? So there are a bunch of inputs. So it's static data, that's kind of static, but there's weather coming in, there's tariffs, these are kind of the fixed things, but then there's prices that are a constant stream of time series data, and telemetry, which is another constant stream of time series data. And that telemetry can actually be quite a large data set for each site. So you want to keep that in memory, so you're making decisions based on the most recent information you have. There are other ways to do that, of course, but this is kind of a really generic diagram of the problems with the other traditional ways of doing it. In a CQRS or eventually consistent model, you're spinning things out, you're dealing without a latency, not dealing with the latency, you're dealing with the throughput, but you're adding latency, and you'll be making decisions on old data, and you'll eventually get bottlenecks. Like if you're trying to load that in and out of the database at any kind of scale, you're gonna have to scale up your database quite a lot. So why not just keep it in memory where you need it to make your decisions? Yeah, so yeah, it always adds latency. Yeah, the database definitely becomes a bottleneck. So yeah, any good DDD talk needs a slide of the blue book. In like in the Blue Book, Eric Evans talks about the traditional ways to isolate the domain, keep it pure, typically done through a layered architecture where you separate your data persistence out from your business logic. And like rereading this recently, he's talking about Java beans, Java entity beans, and I'm thinking and saying that that's a bad example to use, and it got me also wondering, as like grains the Java beans of today, and should they not be used for entities? So yeah, isolating the domain is the biggest pain point I see in treating grains as entities. But it's a balance between keeping purity and like using the most of the tools that Orleans gives you. It's quite a powerful framework. So if we tried to abstract away, would we really be making the most of it? Just showing a couple of examples of the boilerplatey wiring up infrastructural code you'll have to deal with in an entity. So you always have to restore state, you have to write state. If you got something, so that a reminder is a timer. So like you might have we have jobs that execute every 5 minutes. So kind of reminds itself to do something every 5 minutes, but you end up with a lot of this code mixed in with your business logic, and it does annoy me, but is it worthwhile? And yeah, like when I'm looking at the code and I'm seeing that mess mixed in with my business logic, I really want to strip it out. But in experience, having used this for quite a few years now, that when you look at a grain, it does end up very closely representing what you would want as a what I think of as a pure DDD entity. So I think it encourages you to think in that way anyway, pushes you in the right direction just by having that framework there. Even our code base was not designed with DDD principles in mind, but still it ended up in that direction. So for that reason, I think it's pretty good base. I would warn though and recommend that you'll end up with a lot of grains that are not entities just for other reasons. So it might be good to separate those out, or to somehow keep I suggested using like regions to one of the engineers, and it's like it feels like very naughties, and like maybe separate all the wiring up code and keep that clear. But I think the trade-off is worthwhile. So here are some examples from my domain, or from the Evergen domain. Now that you're all domain experts, you could probably agree that, like, you know what a site is. That's a residential address. It has an address on it. You probably know what a EV is, solar battery. These are the concepts that we discuss with our domain experts. Like, they really fit my definition of an entity, and in our Orleans cluster in intelligent control, they are grains as well. But then we end up with a bunch of these other grains that are purely for infrastructural concerns. Like, I definitely don't discuss with people solar prediction gathering or the price event trigger. That's probably a handler somewhere else, but because of the way you want it to interact with multiple grains, you end up making these things grains. So this is where I was referring to about having patterns to separate out the entities from the other grains could probably help steer you in the right direction a bit. Interesting aside maybe here, since DWD audience is inside Orleans, we consider each of those an aggregate, like so each of these devices and is its own aggregate. That's because there's constant state coming into that and we don't want to have to save everything all at once. So for example, telemetry is coming in and then you don't want that life cycle attached to the site. So then you have to persist all the other attached grains. But outside of Orleans in our site management context, they are one aggregate root, aggregate with site as the aggregate root. So overall, is the trade-off worthwhile? Yeah, and I didn't think it was at the start, but now after preparing this talk, I do think it is. So my metric, it's working in production for almost exactly 5 years. I think, yeah, like Ford. Yeah. that was the launch of it into production. So yeah, it's currently right now it's controlling 20,000 sites. We're able to iterate on it, like it went from solar battery only to controlling those other device types, controlled loads and EVs. It wasn't a lot of work, and it really supported the growth in that. So I'm actually more happy with Orleans now than when I started preparing this talk. And so I'm selling it a bit more. And yeah, that's it. And I just want to thanks to Emad, Timo, Roussel, and Francois, who actually wrote all the code. I've done like 2 PRs in it, so it's not, I can't claim credit for this. That's it. Thank you.